In the economy, there's a circular flow of income and spending. Everything is connected. Money that is earned flows from one person to another, and most of it gets spent again, not just once, but many times. What this means is that small increases in spending from consumers or investment or the government lead to much larger increases in economic output. Economists use formulas to measure how much spending gets multiplied. To illustrate this, let's take a look at a very simple economy featuring these four familiar faces. Bob, the lawn service guy, who also does landscaping when his customers are interested. Lydia, a neighbor who works on an assembly line in a car factory. Frank, who's a farmer. And finally, Davis, who recently moved into the neighborhood and works at the hardware store. Lydia's factory has a great year, and as a result, she earns an additional $1,000 of income. Lydia, very eager to satisfy her own needs and wants, spends $800 of it on new landscaping for her yard. Well, since Bob's in the landscaping business, that means that Bob earns an additional $800. Since Bob also has needs and wants, he spends $600 of that $800 at Frank's farm store. This money is additional income to Frank the farmer, and guess what he does with it? He goes and talks to Dave and spends most of it, let's say $500, at the hardware store. As you can see, the initial $1,000 round of spending actually led to 3 more rounds of spending, with smaller amounts each time. In this case, $1,000 of spending from Lydia led to an increase in economic output of 1,000 plus 800 plus 600 plus 500, which equals $2,900. When money spent multiplies as it filters through the economy, economists call it the multiplier effect. Money spent in the economy doesn't stop with the first transaction. Because people spend most of the extra income they get, money flows through the economy, one person at a time, like a ripple effect when a rock gets thrown into the water. I'm sure you can remember a time when you were standing next to a pond or a lake, and when you threw a rock in, you gazed at the ripple effect that took place around the rock as it entered the water. Spending in the economy is like this. The question we want to answer is this. How do we measure this ripple effect? And here's a real-world example that happens more often than you might think. Let's say that the economy is in recession, and consumers like Lydia have stopped spending money, so economic output has gone down. It just so happens that you're working in Congress. And let's say you have a really big desk and a corner office and a statue of an eagle with a bar of gold in its claws, mostly because it sounds really cool and I'd love to be staring at a bar of gold all day. You're on the committee that's working on a bill to increase government spending. Why would you want to do that? Because the economy is in recession and government spending is one of the components of economic growth. You know that if consumers like Lydia have stopped their spending, that maybe some government spending will help increase the output of the economy, and it will ripple through the rest of the economy. And maybe Lydia can get the landscaping that she desperately wants after all. What you really want to know at this point is, how much will output increase if government spending increases by $1 billion? At first glance, you might think that output will increase by exactly the same amount as government spending increases, but you'd be incorrect. When the government spends money, firms profit, and when firms profit, workers take home more income, which then gets spent. Because of this multiplier effect, output goes up by a much larger number. And we can find out how much by using what economists call the simple spending multiplier. The simple spending multiplier shows us how much economic output increases with an increase in spending. Economists ask the question this way: how much did real GDP change when a component of aggregate demand changed? To understand the simple spending multiplier, you also need to understand how likely people are to spend versus save any extra income they get, because this determines how big the multiplier effect will be. Economists call these two other concepts the marginal propensity to consume and the marginal propensity to save. The marginal propensity to consume is the percentage of extra income that consumers spend. Economists call it MPC for short. So, if the MPC is 80%, that means consumers are likely to spend or consume 80% of any extra income they get. The marginal propensity to save is the percentage of extra income that consumers save. Economists call it MPS for short. It's basically the inverse of the marginal propensity to consume. Because we're talking about a percentage of income, both of these percentages will always add up to 100%, or 1.0. The easy way to think of this is to say, whatever the MPC is, subtract this amount from 1, and you get the MPS. The MPS is 1 minus the MPC. For example, if the marginal propensity to consume is 0.8, which is 80%, then that means the marginal propensity to save must be 0.2, or 20%. When the MPC is 0.85, on the other hand, then the MPS must be 0.15, etc., etc. The MPS is actually one of the components of the simple spending multiplier, which is why we need it right now. Our original question was, how much would economic output increase with a $1 billion increase in spending? And we used the simple spending multiplier to figure this out. The formula for the simple spending multiplier is 1 divided by the MPS. Let's try an example or two. Assume that the marginal propensity to consume is 0.8, which means that 80% of additional income in the economy will be spent. What we want to know is, what is the maximum amount that real GDP could change if government expenditures increase by $1 billion? So first we find the marginal propensity to save, which is always 1 minus the marginal propensity to consume. The marginal propensity to consume is 0.8. So 1 minus the MPC is going to be 1 minus 0.8, which is 0.2. Now we take the additional spending of $1 billion and multiply it by the multiplier, like this. Spending times 1 over the MPS, which would equal $1 billion times 1 over 0.2. And we know that 1 divided by 0.2 is the same as 5. So now we have $1 billion times 5, or $5 billion total. So the maximum amount that real GDP could increase when government spending increases by $1 billion is $5 billion. Now you can see the results of the multiplier effect. An increase in government spending led to an increase in economic output that was 5 times as large. Let's try another one. Let's say that net exports increase by $100 million, and the marginal propensity to save is 10%. Notice this time we know the MPS and didn't have to calculate it from the MPC. Using our formula of spending times 1 over MPS, we get $100 million times 1 divided by 0.1, which is equal to 100 million times 10, or $1 billion. That means that an increase of net exports in the amount of $100 million leads to an increase in real GDP of $1 billion. Again, this is the multiplier effect at work in the economy. When you think about it, the MPC and the MPS are the key to this formula. When they change, the multiplier effect changes. Since the simple spending multiplier is based on the marginal propensity to consume, any increase in the MPC will increase the value of the multiplier. Likewise, any decrease in the MPS will increase the value of the multiplier. Okay, let's review. When money spent multiplies as it filters through the economy, economists call it the multiplier effect. Money spent in the economy doesn't stop with the first transaction. Because people spend most of the income that they get, money flows through the economy one person at a time, like a ripple effect when a rock gets thrown into the water. The marginal propensity to consume is how much, in percentage terms, of extra income that consumers will spend. Economists call it MPC for short. So if the MPC is 80%, that means that consumers are likely to spend or consume 80% of any extra income that they get. The marginal propensity to save is the percentage of extra income that consumers save. Economists call that MPS for short. It's basically the inverse of the marginal propensity to consume. And because we're talking about a percentage of income, both of these percentages will always add up to 100%. We use the simple spending multiplier to estimate how much total economic output will increase when some component of aggregate demand increases. The formula for the simple spending multiplier is as follows: 1 divided by MPS. To use it, simply multiply the initial amount of spending by the simple spending multiplier.